Hi there. Thanks for joining us on another edition of Space Nuts, where we talk astronomy and space science. My name is Andrew Dunkley, your host. It's good to have your company as always. Today, we're going to start off with something quite controversial, and in some parts of the world, they'll probably call this dumb, but a proposal to create a sunlight service. Yes, using mirrors in orbit. It's a thing. Also, a near miss for Earth involving asteroid 2025 TF. The 6,000th exoplanet has been discovered, and another potential subsurface ocean. This one involving the moon Mimas. That's all coming up on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining us in the stead of Fred Watson, we are joined by Jonti Horner, Professor of Astrophysics at the University of Southern Queensland. Hello again, Jonti.
Good morning. How are you going?
I am well, and we should just put a caveat to this episode. There might be noise because you're getting work done at the house.
Yes, and of course, we organised to record at this time prior to the tradies getting in touch and saying, you know what, we'll be there at 7 a.m. on Monday morning. It's like, great! We'd want this done. Hopefully the wonders of the microphone will filter it all out, but given that some of the banging I can feel through my feet, I suspect the vibrations might go all the way through the desk and all the way up the microphone, and we'll occasionally get bang, 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 drill, drill, drill. So, yeah, I know, consider it like we've got a craft work gig going on next or something like that.
Well, I can tell you we've heard worse from Fred's house, so
yes.
it shouldn't sound out of the ordinary, to be honest.
Yeah.
All right, let's get stuck into these stories because we've got a lot to talk about. This first one, I know you sent me the information initially that came from, I believe, one of your students who's overseas. But this is an idea of a Californian company who is applying to the Federal Communications Commission in the United States, the FCC, for permission to launch a satellite into space to reflect sunlight back down on Earth and charge people for the privilege.
Yeah, now I try very hard to be even-handed and to not be too critical, even when I'm talking about the people who shall not be named, the ones who are putting up Starlink satellites and abusing colleagues of mine, or people who are claiming that things that are not aliens are aliens in order to sell books. I try and be even-handed, and it's very hard to talk about this one without getting a bit caustic. It reminds me of the late, great Terry Pratchett, who in one of the books was talking about a certain subset of the landed gentry. There's political things going on, and this is a time when the city's under siege and they're reforming the regiments and things like this. And it's talking about the boys who were dropped on their heads as babies, as this kind of subset of nice but dim gentry. Yeah. Now, they're nice, but they're not all there. And this, to me, seems like an idea that was dropped on its head as a baby. It's so overwhelmingly dumb that you think it must be April 1st, and it isn't. So the idea that this company called Reflect Orbital have, and it's an idea that has led to them getting tens of millions of dollars of funding. So it's not like, this is... It's not like these are people in the pub saying, we've had a few, what would be funny. This is a company taking it seriously. They're getting interns in. They've got a very active social media presence. And their whole business is, isn't it sad that it's dark at night time? Wouldn't it be great if you could pay somebody and get sunshine delivered to you at night? And that could power your solar panels, or it could help you grow your crops, or, help you illuminate your sporting event or your concert.
Mm.
And the idea that they've got is that they will launch satellites into low Earth orbit, maybe 400 kilometers up. They will go around the Earth every 90 minutes. So they're going to be fleetingly above any given location, above the horizon for a few minutes. And if you send them a few of your dollary dues, they will make their satellite reflect light down to your location and deliver sunlight to you. Now, there's all sorts of problems with this. Firstly, I live in Toowoomba. I'm 27 degrees south, and I can see satellites that are about 400 kilometers up in about the first hour after sunset, the first hour before sunrise. The rest of the night, those satellites are in shadow too, so there isn't any sun to reflect.
Oh, so, fair point.
nobody seems to be really mentioning that in the narrative of how this will work.
Yeah.
But even ignoring that, think about the International Space Station going overhead, and you can get predictions of this from wonderful websites like heavensabove.com. And the space station becomes visible, passes over, and then goes into the shadow. And you might get 5-6 minutes of it going overhead if you're lucky.
Yeah.
And then it's gone. So you have this idea that these mirrors that they're going to launch are about that altitude. And if you want them to illuminate a single point on the ground, they've got to be turning so they keep rotating the light to that point as they pass overhead.
Mm-hmm.
When they've passed overhead, what do? They can't just turn off the mirror. So is that suggesting that you're going to have a beam of light sweeping across the countryside at orbital speed, like when you're trying to entertain a cat and you're shining a laser pointer on the floor and the cat's chasing it, you've got a beam going across the Earth.
Yeah.
Going across the skies of all these people who didn't pay for the service. Not just that, how do you get enough sunlight down to be functional? So these satellites are going to be small enough to launch. So you're talking about a mirror a few meters across, 400 kilometers away, trying to reflect sunlight down. And they talk about how the diameter of the beam will be about 5 kilometers across. So that means if I pay for them to deliver light to my backyard, anybody in a 5 kilometer diameter area around me
Also
will get illuminated as well for free, whether they want to or not.
Yeah.
But not just that, the light's not going to be that bright, because if you've got a 1 meter size mirror reflecting sunlight, and then you spread that light over an area that is 5 kilometers in diameter, you're spreading that light awfully thin. So any area on the ground there is not going to see broad daylight. They're going to see something that is comparable in brightness or a few times brighter than the full moon, which is, okay, that's enough light for you to go out and do something in the backyard by, but it's not particularly enough light to get really effective solar power from.
No.
So if you want to make this effective, you're going to have to launch hundreds of thousands of these mirrors, all to work in concert to beam towards a given location, which doesn't sound that feasible. Add to that the fact that these are big floating targets in space that space debris can hit and smash, which means that A, you could get all this debris scattered off in all sorts of different directions, but also that it's going to be hard for them to control the direction the mirror's pointing.
Mm.
So you've got all sorts of problems here. I mean, I think there's growing and demonstrated evidence, and Fred's talked about this to death, about all the negative effects artificial light at night has.
Yeah.
We've got effects on people. You've got increased cancer rates. A very bizarre but very significant link between light at night and an increased risk of breast cancer for women, believe it or not.
Wow.
Just as one example. You've got the impact in our circadian rhythms, the fact that we need it to be dark to sleep.
Yep.
Then you've got all the impact on flora and fauna. Now, I've visited some wonderful places on the coast of Queensland to do outreach sessions, some guided night sky observing. And a lot of these places are places where turtles nest. In fact, I'm going next weekend to the wonderful Lady Elliot Island on the reef to do some outreach, and I go there several times a year, and all of their resort is designed to keep light down and pointed at the ground and have lights that get turned off.
Mm.
Because the baby turtles, when they hatch, they navigate to the ocean by looking at the very faint light on the horizon, light reflecting off the ocean. And that's what sets their internal compass as they start their lives. And if you have stray light, they go the wrong way and they end up under the buildings and on the road and things like this.
Yeah.
So there's huge impacts on life. But I think the biggest concern about this is a safety aspect. You're driving around, and I know here in regional Australia, most of our roads don't have streetlights, and that's perfectly fine. It's safer as such. You drive along with your full beam on, and any kangaroo that you see, you've got room to do something about it. So you're driving along on this pitch black road, and suddenly from nowhere, something brighter than the full moon shines full head on in your view. You're dazzled. That's hugely dangerous.
Yeah.
Bad enough if you're driving on the ground. If you're a pilot coming into land, and suddenly somebody shines a spotlight in your face, that's not going to be a particularly pleasant outcome for you and the passengers in your plane.
Mm.
And so there's all these issues there that any one of them would be enough for you to say, this is a really foolish idea. It is not something that is likely to work anyway, but it's a really foolish idea from the ground up. It's only going to work near twilight. You're going to have to launch thousands of satellites to make it work. But it isn't stopping people funding them. And this company, like I say, has applied to the FCC in the US for permission to launch the first of these satellites, which they've named Arundel-1 after the light from Lord of the Rings. Arundel-1, they're hoping to launch April, May time next year, 2026, to demonstrate that their wonderful, great idea can work. And it's just yet another example of this kind of Wild West scenario we've got with the use of space around the Earth, where the use of space is really outstripping our ability to regulate and control that use. And people are doing things because it seemed like a good idea at the time without any real thought about the practicality of it, whether it could work. And normally you just think, like say, you think this is an April Fool's Day kind of prank. But the fact that this company has raised tens of millions of dollars in kind of venture capital, it's supported by a multi-billionaire, is really, really concerning. And that's why a group of astronomers, including Jessica Heim, who's doing a PhD with me at UniSQ, have put out this fact sheet with loads of information, loads of links, number of astronomers in the US who people in the media can contact for more information, and suggestions about what people can do to flag up how catastrophically dumb this is. And that includes submit comments on the application to the Federal Communications Commission in the US to demand an environmental review of reflected light from orbit, contact government representatives, particularly in the US, but also locally where you live, to try and raise noise about this. But also tell people about it and point out how dumb it is. Because I can understand that if you don't really think about this too much, you can think, yeah, there are times it'd be really nice to have a bit of extra light at night. I didn't get round to doing the gardening. It'd be good to mow the lawn tonight. Wouldn't it be great if I could just turn on the spotlight and have half an hour of my backyard being daylit at night for me to do that job? And you need to talk about it and you need to think about it to see why this is just so catastrophically dumb in so many ways that you would have thought it had been on starter, but yet they're getting money.
I can't see or understand any logic in this.
Yeah.
And the way, in low Earth orbit, as you said, there's only going to be a few minutes of light. It's not like they can light a stadium for 4 hours straight, not yet anyway, but even if they could, that's going to take a lot of hardware up in space, and there's more light pollution on Earth, which is a big problem. Fred and Marnie are so heavily involved in the Dark Skies project. This would just blow that out of the water.
Well, it would. And I mean, to light that stadium for 4 hours, you would need mirrors going overhead continuously in a parade. You'd need that stadium to be near enough to the pole and it to be summertime that those satellites were always in sunlight. Or you'd need to put them further from the Earth. The further you move them from the Earth, the more spread out the light will be.
Yep.
And so therefore the more satellites you'll need. And if you get to that stage, if you've got that many satellites in orbit around the Earth, you may as well build a mirror that is held in geostationary orbit that covers half of the size of the Earth and bathes the entirety of that side of the Earth in sunlight. And, while you're at it, you're increasing the amount of heat coming to the Earth and will just speed up global warming and kill everybody.
There is a groundswell of discontent, as you mentioned, so people are starting to make some noise about this. I hope the FCC, looks at both sides of the story. How likely are they to get their license and start testing this?
I mean, a pessimist would say it's almost certain to happen because, the FCC are quite happy for Starlink to be putting up the number of satellites they are, looking at 42,000 long term. So it doesn't seem like there's much thought of that. And there's the added concern, I think one of the things that is hindering legislation is the fact that you can launch to space from many, many countries. And so companies can quite rightly say to a given legislating body, if you don't give us this, we'll just take our business elsewhere and someone else will. And, once you're launched from a given country, you're above all of the countries of the world as you move over them in your orbit. So it isn't like this thing is just going to affect people in the US because it's been launched from the US. It's going to be going around the Earth, like I say, running a 5-kilometer size beam of light across the surface of the Earth every 90 minutes as it goes round and round and round and round.
It just doesn't make much sense, really. It sounds like pie in the sky, but they're actually seriously considering doing this. And hopefully common sense will prevail, but time will tell, I suppose. We'll know next year whether or not they start testing these things. I know they did do this some years ago with a mirror array up in space, and they lit up a spot on Siberia or something. Yeah, I don't know why they did that then. I can't remember, but it was somewhat successful, although quite dim. But this just, yeah, I mean, I don't know where it stops. There seems to be this constant tug of war between what we need up there and what we don't need up there, and it's swinging the wrong way at the moment, I suppose, would be the way to describe it. But I dare say this will get a lot more press and a lot more pushback, and maybe the FCC will look at the problems associated with this.
I really hope so. I mean, it reminds me, and I'm probably paraphrasing terribly, but there's a famous science fiction quote, something along the lines of, they spent so much time and effort trying to show that they could, that they never put any thought into whether they should. And it feels like one of those.
Yes, indeed. All right. It's a project you might find online. It's only just sort of starting to emerge. I don't know how much press it's got yet, but it will grow because it's one of those stories that is also fascinating, and they're the ones that generally get a lot of attention.
Looking at their website, the company seems to have been around for quite a while, and I think it's probably getting attention now because previously everybody thought, well, no, this will never fly. This is clearly not something we should be worried about. And now it's very clear that actually it is, because they're paying for licenses and they've got a lot of money invested.
Yeah. And one wonders who is really going to pay them to shed a little light on their whatever. I mean, what would you use it for? I don't know. Solar panels, you said they won't work. Football matches, well, we've got lights for that. I mean, I don't know.
We can do a bit of quick mental arithmetic to cheer everybody up. I mean, the brightness of the full moon, to first order, very roughly, is about magnitude -12 in the wonderful complex magnitude system astronomers are so fond of. The brightness of the noonday sun is about magnitude -27. So that's a 15 magnitude difference. Now, that magnitude system is a logarithmic scale. So every 5 magnitudes you're brighter or fainter than something is equivalent to a factor of 100 in flux. So if you're 15 magnitudes, that's 3 lots of 100. So 100 times 100 times 100. That's 100 becomes 10,000, becomes 1,000,000. So if the light from this thing is about the brightness of the full moon, it's 1,000,000 times fainter than the sun is. So if you've got your solar panels that are generating in full sunlight, a few hundred watts of power, right? They're generating a few hundred watts. Divide that by 1,000,000, and you're not generating enough to register.
Yeah. It would be like putting up a solar panel to power a light and using that light to generate the power to power that light. It's just
absolutely. Or just holding a lit match near your solar panels and expecting it to run your entire house.
Yeah, it's crazy stuff. All right. Keep an eye out for that story, and if you feel strongly enough about it, maybe get involved. Yeah. Let's move on to our next story. This involves a near miss for Earth, with asteroid 2025 TF just skimming us. And we didn't see it till it was too late, technically speaking. And it kind of dovetails into the previous story, because if there's going to be more light up there, it's going to make things harder for us in terms of getting these ready alerts for potential objects that could strike Earth. This one wasn't huge, but it was there, and it was a detectable object, and we didn't see it.
Yes, and that's the issue. Now, this thing, quite happy to say straight up, the size of this thing is such that it would have put on a nice light show as it, was quite harmlessly destroyed in the atmosphere. It was probably about 1 to 3 meters across.
Yeah.
But of the things that have not entered the Earth's atmosphere but have come close, this is the second closest on record. Now, back in, I'm trying to remember exactly when the Great Daylight Fireball was, but in the early 1970s, there was a fireball observed widely over North America, which was what we call an Earth grazing object, and it actually hit the atmosphere and skimmed back out. That is not counted when people talk about these two closest encounters that didn't hit Earth, because technically that did hit the atmosphere. The fact that it skipped back out again is beside the point. And that was a daylight fireball. It created sonic booms over a couple of the US states, and was really the first kind of fireball event that was widely captured, because it was early in the era of modern holiday snaps. And this was a time when people were taking photos on holiday, then boring their friends when they came home.
Yeah. 1972 it was.
That's the one. Yeah, I thought it was. It was Probably something smaller than a house that came within about 57 kilometers of the surface of the Earth. And to put that in perspective, that's like, the old William Tell thing of shooting an apple off somebody's head. That's like shooting the arrow at the apple and touching the skin of the apple without breaking it. It's coming within less than 1% of the diameter of the Earth of actually hitting our planet. This one wasn't quite that close, but it's an object that was discovered by the Catalina Sky Survey a few hours after its closest approach to the Earth. Basically, it whizzed over Antarctica, so I think it's one of those that even if it had hit the atmosphere and burned up, very few people would have seen it, but a lot of penguins would have been impressed. At its closest, it was 428 kilometers above the Earth's surface, so that's slightly closer than Reflect Orbital want to put their mirrors. So if it had come through a few years later, we could have hoped it would have knocked a few of them out of the way, but it's a really close approach. And yes, it's an object that in this case wouldn't have been big enough to cause any damage, wouldn't have had any impacts felt at ground level. It may have, if it was made of the right stuff, dropped a few little bits of meteorite on the surface, but that's about it. But it's a reminder of the fact that as we're looking for things that come close enough to the Earth to pose a threat, we haven't found them all yet. Now, probably about 75% of the threat to the Earth from impacts comes from the near-Earth asteroids, and they're objects that are born of the asteroid belt, typically rocky or metallic objects moving on orbits at a relatively short period in the inner solar system, and they're short-lived. If you come back in a million years, most of the ones we currently know will have been removed. They'll have been ejected from the solar system or collided with a planet or fallen apart or fallen into the sun. But they're continually being repopulated from the asteroid belt. Some of them hide closer to the sun than we are and then pop out to say hello. We were talking about that last week with the objects near Venus. But there's this effort to try and find all of them. And the earlier you can find them, and the earlier you can figure out if there's going to be an encounter with the Earth that poses a threat, the better the odds of you doing something about it. And we saw this kind of a bright light shone on this back at the start of 2025 with the object 2024 YR4, I think the name was, that for a while we thought had a substantial possibility of hitting the Earth in 2032, that we now know is not going to hit the Earth but might hit the Moon in 2032. And that was a big success because we found it early enough to get a lot of data, and over the course of about a month, astronomers observed it repeatedly until eventually we showed that it definitely wasn't going to hit the Earth in 8 years' time, and everybody kind of basically jumped up and down and said hooray, and there was much rejoicing. So that's like the ideal scenario. We find something when it passes relatively nearby on one apparition a few years before it would realistically pose a threat. And that's what we want to achieve. And the stated goal of a lot of the agencies looking for these things is to find all the objects bigger than about 100 meters across that could pose a threat to the Earth and catalogue them. And we haven't managed that yet. We even more haven't managed that when you take into account things like comets. We were talking about Comet Swan last week, which appeared from hiding behind the sun and came and was suddenly the brightest comet in the sky. Comets are coming in on orbits that take hundreds, thousands, sometimes even tens of thousands or millions of years to complete. So even if we find all the near-Earth asteroids, we're still going to have comets coming in, so we'll have to stay vigilant and keep watching forevermore. But this is a real good reminder that despite how you feel, we're not there yet.
Yeah,
we are still in a position where these things are catching us by surprise. And the worst case scenario is what happened in 2013 with the Chelyabinsk impactor, to a similar level of what happened with Comet Swan earlier this year, in that as the object approaches the Earth and eventually gets close enough that it was visible in the nighttime sky, would be able to detect it. It's coming from the sunward side of the Earth, so it's hidden in the glare of daylight. And so that's why you don't want to try and detect something the moment it's on an approach to hit you. You want to find it well in advance.
Yep.
And with Chelyabinsk, it demonstrated something big enough to injure people, damage a city. We didn't find until it was in the atmosphere, and it was kind of too late. It was seconds from disaster.
Indeed.
Now, there's hope. We've got Vera Rubin coming online. We saw beautiful pictures from that earlier this year. Vera Rubin's going to start getting data regularly, continuously later this year, early next year. That's when the Mayan mission starts. And Vera Rubin's going to be an exceptional thing-finding tool. No matter what the thing is, it will find more of them than anybody's found before. From a solar system point of view, we're really excited because it will increase the number of objects we know by a factor of several to an order of magnitude within a year or two. And it'll be great at finding these things, but it'll be less great than it would have been thanks to all the stuff we keep launching there. And this is where it ties into the previous story. Also ties in again to the wonderful student who sent me the information about the reflect orbital stuff, Jessica Heim. He's finishing up her PhD with us at UniSQ. She's based in North America, and she's done a lot of her work about light pollution and artificial light at night and things like this. And one of her papers early in her PhD that she was a co-author on was in Nature Astronomy, and they actually did a study looking at just the Starlink satellites that were in orbit at that time, so not the predicted number in the future, and tried to quantify how much harder they would make life for Vera Rubin, and particularly how much harder they make it for Vera Rubin to find objects like the one we're just talking about that whizzed over Antarctica. And what they found was the Starlink satellites that were in orbit at the time, so not the constellation we have now, which is bigger, not the final constellation, would make it 10% harder for Vera Rubin to do its job. So in other words, it would have to observe for 10% longer, roughly. I think the number was actually slightly higher than that, in order to achieve the same results. Now, when you're talking about a facility that's $1 billion level facility, hundreds of millions of dollars to build, having to take 10% longer to do something is a cost measured in tens of millions of dollars.
Yeah.
That's the real impact in this. And what it means is that things like this are going to be harder to find, and our ability to detect potential threats is really kind of confused and obfuscated by the stuff we're putting to hang around in the foreground. It's like, I guess it's really easy to see a road sign on a clear day, but when it's foggy, it's a lot harder to spot it until you're right on that sign.
Yeah, yeah. Indeed. And if you want to read up on that story about the near miss, you can do so at space.com. This is Space Nuts with Andrew Dunkley and Jonti Horner. Let's take a break from the show to tell you about our sponsor, NordVPN. And we're very proud to have partnered with NordVPN so that we can get you more secure online, no matter what you do, where you are, or how you do it. Now, if you sign up for a 2-year NordVPN plan using the code word SpaceNuts, you'll receive 4 extra months absolutely free. That's 28 months of top-tier VPN protection at a fraction of the cost. With NordVPN, what you get is access to over 7,700 servers worldwide, ultra-fast connections, advanced features like Threat Protection Pro and MeshNet, and secure usage for up to 10 devices simultaneously. So you're pretty well covered, you have to admit. Now, this is a great opportunity, and if you'd like to take advantage of it, visit nordvpn.com/spacenuts to claim your exclusive offer today. And remember, with NordVPN's 30-day money-back guarantee, it's risk-free. It's a great investment, a small price to pay for your online security and privacy. Stay secure, stay connected, and keep exploring the cosmos with confidence. nordvpn.com/spacenuts. nordvpn.com/spacenuts. And don't forget the code word SpaceNuts at the checkout. Now, back to the show.
0G, and I feel fine.
Space Nuts.
Now, Jonti, we have found the 6,000th exoplanet. It took us 30 years, which is, if you look back at when we found the first one, it was quite a surprise for a bunch of reasons, mostly because we didn't even know they could have existed beyond our solar system. Logic suggests, if we've got planets around our sun, other stars must have planets too. And 30 years ago, that was proven. Well, now we're up to number 6,000. When are we going to stop counting? Because it's going to reach a point where we're going to find millions upon millions of these things, isn't it?
It is. And even the counting's a little bit confused because the resource that I trust as kind of being the authoritative word on this is the NASA Exoplanet Archive, which is a wonderful resource. And they've got a certain threshold for what they consider a confirmed planet. And we've got all these candidate planets as well, of which there are thousands more, where we're fairly confident there's a planet there, but it doesn't meet that rigorous criterion. There is a different exoplanet catalogue run out of Europe that has a number higher because they are less strict on their criterion for confirmation. Part of the reason I'm more sceptical about that catalogue is that there's a number of planetary systems I've helped to kill, and they've left them in their catalogue. So we know for a fact those planets aren't there. I did some of that work, and they still include them in their catalogue, which puts them on my naughty list. So I prefer the NASA one. And the NASA one is the more cautious of them. It's really interesting how this has come, though. You know, I'm 47 now. I don't feel it, but I'm getting on a little bit. I was a kid who was mad about astronomy, you know, like some of the people who send in their questions, some of the youngsters who send in questions. And when I was growing up, one of the questions I'd have been asking is, do you think there are planets around other stars? We'd had observations from satellites like IRAS in the 1980s that indicated there was dust and debris around some stars. But at the time, our models of planet formation fell into kind of two camps. There was what's now become kind of the standard baseline with some tweaks, which was that you get a disk of material around every young star and planets form in it, so most stars will have planets. But there was a competing theory that said that the planets were formed by a very close encounter between the sun and a passing star that pulled material out of the sun like a tongue of material, and the planets formed from that. And there are people who were very strong advocates of that. Now, the test of those theories, it would have been, are there planets around other stars? Are they common? Because the idea that two stars get close enough together to have this tidal interaction, pull out a tongue of material and planets form from that, would suggest that planets would be overwhelmingly rare in the cosmos. So the likelihood of two stars getting that close together and having exactly the right conditions would mean that planets were pretty much non-existent, that they were a fluke of nature.
Yeah.
The other model suggested that planets are common. And so one of the goals in the early 1990s with the search for planets elsewhere was to see whether there were any at all, and we just didn't know. The discovery of 3 planets around a pulsar in the early 1990s broke everybody's heads. Those planets have now incidentally been called Drow, Phoebiter, and Poltergeist, which are names of different types of undead from different cultures around the world. And I think that's kind of cute because you've got zombie planets around a dead star. That's all good. But 30 years ago, and actually 30 years ago last week, on the 6th of October 1995, we saw the announcement of the first confirmed planet around a star like the Sun. And that planet was 51 Pegasi b. So it's a planet going around the star 51 Pegasi. And it immediately broke everybody's heads because it was not what we expected. So both our models of planet formation that were based on a grand total of one planetary system, our own, predicted you'd have rocky planets close to the star and big gas giants a long way from the star, because that's what we see at home, and that makes sense.
Yep.
So to find a planet similar to Jupiter, but going around its star every 4 days with a surface temperature in excess of 1,000 degrees C was not what was expected, I think would be the polite way to put it. Now, that forced people to immediately go back and start revisiting and improving that disk model of planet formation, which has kind of led us to where we are now. But that was kind of fundamental and foundational. For the first decade or so after that discovery, new planets were found in dribs and drabs, and the rate at which they were discovered gradually increased. And in that first decade, the best technique for finding planets, the one that was most successful, was what we call the radial velocity method, which Australia really played a leading role in with the Anglo-Australian Planet Search. There was this beautiful spectrograph attached to the 3.9-metre telescope at Siding Spring, which I know Fred loves dearly. It's a real icon of Australian astronomy.
Yeah.
And that telescope was used to point at one star, measure that star's speed, then point at another, and gradually survey this collection of stars, and then keep coming back to them every now and again and measure their speed again. And by measuring the speed of these stars to the level that you can see them wobbling at with changes of speed measured in a few meters per second, so comparable to speed people walk or jog around, stars that are trillions or quadrillions of kilometers away, measuring their wobbles to a precision of meters per second, that just makes my head hurt. But by doing that, you can spot the telltale wobble of a star rocking back and forward in space and infer the presence of a planet. But it's a really time-consuming, challenging method where you can only observe a few stars at once, because you've got to gather light for an hour or more to get enough light to get an accurate enough spectrum to get a single measurement, and you can only point at one star at once. By the late part of the first decade of the 21st century, the transit method started to take over, and this is where we look at a lot of stars all at once and look for the few of them that are winking at us. So they've got a planet going around them that's lined up just right, that every time it goes around that star, it will block a bit of that star's light, and the star will dim and then brighten again. And that started to take over from the radial velocity method purely because of the numbers game, because you can look at a large number of stars at the same time. And even if only 1% of those stars have a planet oriented in the right direction for you to have it line up and give us a dip, by looking at 100,000 stars at once, you'll have plenty of candidates. The Kepler spacecraft launched in about 2008 and became this first census of the night sky. And it discovered on its own more than 3,000 planets around other stars using this transit method. So we've got better and better at doing it. And over time, what's happened is we've not only found the low-hanging fruit, the really big planets close to their stars that give a whopping great signal that you can find, but with each generation of new instrument that's gone up there, we've got better at finding planets that are further from their stars, better at finding planets that are ever smaller, finding planets that are weird. Other techniques are coming online that allow us to do things another way. And I still think one of the greatest movies that never won an Oscar are the wonderful images of the star HR 8799 that shows 4 planets going around it. And we've got kind of a live movie of those planets orbiting that star that runs back more than a decade now. It's just breathtaking.
Yeah, I saw that.
Yeah, it's awesome. And we've basically lived through this awesome scientific revolution without really realizing it. You know, we've gone from a world where nobody knew if there were planets around other stars to a fact that there is nobody younger than the age of 30 now who grew up in that world that you and I grew up in, where we wondered if there were planets around other stars. It's absolutely breathtaking. We've had real big involvement with this here in Australia. The Anglo-Australian Planet Search was one of the leaders for the first 10 or 15 years of this exoplanet era. We've got a facility here in Queensland that is now leading the way, one of the leading facilities in the entire planet, you know, the only dedicated exoplanet search facility in the Southern Hemisphere, and we work with NASA to do this. We've been directly involved with 41 planet discoveries in the last couple of years using NASA's TESS mission and working with them. But it's this kind of ongoing exploration, this ongoing search. And, you know, what will the next 30 years bring? That's kind of what I wonder. Where will we go with it? And it's not so much when will we stop counting, but when will we start to get things that really potentially could be like the Earth? And I've said this before, I don't think we've found an Earth-like planet yet. We've found things about as big as the Earth that are very different. Like saying, you know, I went swimming last week and I saw the most human-like creature I've ever seen, and it was a dolphin. It was about the same size and weight as a human, but it's fundamentally not a human being.
Yeah.
But we're going to be moving forward, and we're going to be moving from just finding these things to learning more about them. We're moving into this era of characterization. And I think the number's going to gradually lose importance. You know, when we find 10,000 or 100,000, the difference will be a lot less significant than the difference between 0 and 1. But it'll start being which of the planets we know the most about, what are they like, what can we learn about them? And that's, I think, the journey for the next 30 years.
Yes, and as you said, finding that one planet that is so like ours in size and proximity, orbiting a sun like ours, maybe with liquid water, et cetera, et cetera. Yeah, that is that's the golden goose, isn't it, really?
Absolutely. And we've got this really interesting question about how long has the Earth been in a condition that if we looked at it, it would look like the Earth. So in other words, you know, how long has the Earth been an Earth-like planet? Because when we're talking about a planet like the Earth, we envisage something like the Earth is today with, you know, beautiful blue sparkling oceans and a thin oxygen-rich atmosphere and life teeming and abundant continents that are mottled brown and green and icy polar caps. But for the vast majority of the Earth's history, it has looked nothing like it does now. It's had an entirely different atmosphere. It's not had free oxygen in the atmosphere. It's had periods when it was an enormous snowball, you know, the Snowball Earth episodes. So it's quite likely that for the majority of the Earth's history, we wouldn't recognize it as an Earth-like planet because it would look totally, totally different.
Yeah, that's an interesting point, and that could exist elsewhere in the universe. And we may have seen a planet already that could one day be like ours, but it might be tens of thousands or hundreds of thousands of years before it reaches that point. So that's a really interesting factor to bring into the equation. You said some odd planets. I thought I'd do a bit of a search. These exoplanets that we've discovered in the last 30 years. WASP 76b, It's a hot Jupiter which rains molten iron. I think Fred and I talked about that one. WASP 107b, a gas giant with a density so low it's been described as a marshmallow planet.
Yep.
HD 189773b, it's a planet with an atmosphere that contains clouds of molten glass.
Yeah. That's often described as a blue marble planet, I think.
Yeah. HAT P7b is an ultra-hot Jupiter that's so dark it's nearly charcoal. And 55 Cancri E, I think it's pronounced, a super-Earth with a lava world and sparkling skies. And there's probably more weird ones out there we're yet to find that defy explanation. It's a really fascinating part of astronomy.
It is, and it's that realization that the diversity of things that are out there is far greater than we could have possibly imagined. And it really forces us to revisit and refine our definitions of what a planet is. So historically, people had this idealized boundary at 13 Jupiter masses, where if you're more massive than that, you're a brown dwarf and you're a failed star. And if you're less massive than that, you're a planet.
Yeah.
And we're now finding things that people are claiming are brown dwarfs that are only twice the mass of Jupiter, and things people are claiming are planets that are 20 Jupiter masses. There's a real blurring of that boundary. You've then got one weird object. If you look at what the most dense planet we found is, there's one planet that has a density that is something like 150 times the density of water or something like this. And it's a few Jupiter masses. And we know the density because we know the size because of transits, and we know the mass because of radial velocity. And if you've got the size and the mass, you get the density. This thing is so dense so that it doesn't confirm with any known material. It's many times denser than the densest metal. Gravity pulling things in can't explain it. And so, is it really a planet? There is some speculation that it's actually something that was probably a white dwarf that has somehow been bombarded and fractured, so there's only a few Jupiter masses left. So is that a planet?
Yeah, well, if it was a white dwarf that's been pulverized, I would say no, but gosh. There's
all these other things, planets that are less dense than cotton candy, and it's awesome from a speculation point of view. And it's a lot of the planets we've found are things that if you saw them in an episode of Star Trek or, any of these sci-fi series, you'd think that they jumped the shark, that kind of thing just wasn't possible anymore. They'd obviously been enjoying themselves a little bit too much in the pre-writing session. And yet we're finding these objects that are just so diverse and bonkers that it's untrue. That's part of the fun of it. You never know what we're going to find next.
Absolutely not. And that sort of takes us into our final story, because this is an object that is a little bit weird in our solar system. It's the moon Mimas, but it's also been called the Death Star because it does have that Death Star look about it. It's got a dish-like depression in it where it must have got hit at some stage. But the reason it's in the news now is because it is yet another object in our solar system that may contain a subsurface ocean.
Yes, and it's probably, of all the moons where subsurface oceans have been suspected or detected, it is the smallest of them, and it's probably the most surprising of the lot. The evidence for this has built up over a bit more than a decade and comes from the Cassini mission that spent all that time orbiting Saturn, making wonderful discoveries, most famously, of course, being the geysers of liquid water erupting from the south pole of another of the small icy moons, Enceladus, which was a shock because Enceladus is so small that it should be frozen to the core, so it's a bit of a surprise there's liquid water there. Mimas is even smaller. It's the smallest object in the solar system that is spherical because its gravity has overcome the strength of the material it's made from. And when you look at the calculations people have made at what the minimum size something would have to be in hydrostatic equilibrium, to be an object where gravity overcomes the strength, Mimas is actually a little bit smaller than that, which is interesting. It's a real edge case. And, the fact that it is spherical like it is would suggest that at some point it has not been that strong in the past, so it was probably fairly liquid early on in its formation. But any ocean it had when it was born should have frozen out long ago. And that's kind of borne out when you see the photos that are taken of Mimas. It doesn't look like Enceladus. It doesn't look like Ariel that we were talking about last week. It doesn't look like Europa. They're all places that have obviously been resurfaced, that have flat areas with cracks that look like ice that has been broken by plate tectonics because it's floating on an ocean. Mimas just looks like another cratered ice ball.
Yes.
So there's a few oddities that have built up. One of them is that enormous crater Herschel. Now, Herschel as a crater is almost big enough that the impactor could have shattered Mimas. And if it had been only slightly larger, Mimas would have been destroyed. So it's right at the limit of how big a crater can be before things get seriously bad. But a lot of calculations have shown that if the Herschel crater had formed when the moon was frozen solid to its core, it shouldn't have a central peak. But it has a central peak. Now, that suggests that Mimas was a bit slushy. But if you do the calculations and assume Mimas had a very, very well-developed ocean, that crater wouldn't look like it did either, because it would have dug down into the ocean and splashed liquid water everywhere. So there are suggestions that the Herschel crater formed when Mimas was slushy rather than ocean, when it was fluid enough to get this central peak form, but not so fluid that an ocean was breached. And with the size of that impact, it would have breached one if one was there. Now, I've seen some suggestions from that saying that Herschel must therefore be a young crater because it's tied to this young ocean that is thought to be there on Mimas now. That's one of the suggestions. I'm not necessarily sure that's the case. It may be that Herschel may be older and that there was an ocean in the past. That's still to be sorted. But aside from that, there's been a lot of the data from Cassini linked to how Mimas is rotating and wobbling, suggested that it couldn't be solid to the core unless the core was not in hydrostatic equilibrium, the core was elongated and pancake-shaped. And that just doesn't make sense. And as they got more and more data and more observations, that just doesn't work. And so from the rotation and the wobble of this moon, it suggests that as much as 50% of its volume is liquid water.
Wow.
Which is an enormous subsurface ocean. That's an absolutely incredible ocean. But because of the thermodynamics of it, that ocean can't be old, because if it was old, it would have frozen out already. Now, part of the supporting evidence for this is that the orbit of Mimas around Saturn is not perfectly circular. It's actually a little bit more eccentric than the orbit of the Earth around the Sun. That is not a situation that's tenable long-term. The orbit should be circularized by tidal effects with Saturn. And so the suggestion seems to be that at some point, probably in the last 15 million years, something happened to stir Mimas's orbit up and make it more eccentric, to actually make it a bit more elongated. That increased eccentricity means that Mimas now experiences significant tidal heating from being squashed and squeezed effectively by the gravity of Saturn and also by the other moons. It's in mean motion resonance with a couple of the other Saturnian moons. And all of that means that you're going to get a significant amount of heat dumped into the interior of Mimas, melting that interior and creating this ocean. And the argument for the fact that the surface is not yet smooth and resurfaced is that A, that ocean is young and it's a still developing situation, but also that the crust of Mimas is 20 or 30 kilometers thick, and that's thick enough that it hasn't yet responded to the liquid underneath. And so you've almost got this hidden ocean in a place you wouldn't expect, but where all our observations, all our data is suggesting that the only explanation that works for all of the different things we've observed for it is that this is yet another of this growing catalogue of places where there's a huge volume of liquid water buried beneath an icy surface.
Yeah.
It's absolutely breathtaking work, and it's a really good example of the iterative nature of science, because it's not like this is a new discovery this week. There have been whispers about this for years and papers published about it for years, and alternative hypotheses proposed and disproved and all the rest of it. And all the way through, we're getting more and more certain that this ocean's there. We're learning more about the history. And I guess, again, not only are we learning that liquid water is more common in the solar system, but we're getting reminded once again that the solar system is a very dynamic place, and it's not like everything of interest happened 4,500 million years ago, and now we're in the kind of mop-up phase where nothing interesting happens. There's still a lot going on, and the solar system's dynamic in a way that if we were around when the dinosaurs walked the Earth, it would have looked like a very different place to the place we see today. It's that changeable.
Yeah, absolutely. Yeah. And Mimas is also, if indeed it is another water moon, let's say ice moon, whatever you want to call it, it's starting to show that it's probably more normal than we ever thought. This is, you've got so many others that are starting to be found. Obviously, Europa and Enceladus would be the top two, but Ganymede's now in there, and everywhere. Most of the dwarf moons or dwarf planets in the outer solar system are starting to show these signs. So it could be quite normal here. And as we've already discussed, there was a time where we weren't sure whether or not there were other planets in other solar systems in the universe. Well, it's probably going to be discovered that there are probably a lot more ice moons out there than we could possibly imagine. So
absolutely. And the other interesting thing about this to me is it's not just suggesting that you get oceans and the oceans go away. It's suggesting you can get episodic oceans. Because if this ocean is only 10 or 15 million years old, we've had a lot of 10 and 15 million year old windows in 4,500 million years of time. And what is the likelihood that we just happen to be in the only one of those windows where you've got two temporary oceans at the same time, where Enceladus and Mimas have temporary transient oceans that have only formed in recent times? And for both of them, the logic is the same. They're too small to have had this ocean since they formed. It's got to be a recent thing. Yeah. What is the likelihood that we catch two of them going off at once just by random when there have never been any others? So that's suggesting that these subsurface oceans on the smaller moons come and go and come again, which means that, again, from the point of view of life elsewhere, life that can survive the long freeze is ready to take over during the short summer. And we see that on Earth. It's a really interesting thing that if this is a temporary transient ocean now, it's possibly been there multiple times in the past. And that's why I suspect that the Herschel crater may not have formed with the latest recent ocean, but maybe it's a previous episode of it. We will only know when we get more studies. And of course, it's a really good reason to go back to Saturn to find out.
Absolutely true. Yes, indeed. All right. If you want to read about that story and the previous story about exoplanets, you can go to space.com. And we are done. Jonti, thank you so much.
No, it's a pleasure. It's a lot to talk about. It's always good fun.
It is great fun. Good to see you. That's Jonti Horner, Professor of Astrophysics at the University of Southern Queensland. And don't forget to visit our website while you're online and check us out. You can do that at spacenutspodcast.com or spacenuts.io. And if you'd like to become a supporter of Space Nuts, it's really simple. Just click on the supporter tab. You can become a patron, or if you'd prefer to use another platform, you can do that through Supercast. And there are plenty of different options there. But as I always say, it's not mandatory. If you only want to buy us a cup of coffee, that's fine as well. In fact, some people have literally sent us coffee vouchers over the years. So check it all out on our spacenutspodcast.com website. And I would say thanks to Hugh in the studio, but he's out counting exoplanets and he got to 10 and you can't count any higher. And from me, Andrew Dunkley, thanks for your company. We'll see you on the next episode of Space Nuts real soon. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.